Hi all, welcome to Easy Math, making math easy. In the previous video, we got introduced to heights and distances in trigonometry. We solved a couple of problems. We saw how to mark the angle of elevation and the angle of depression, how to convert angle of depression into angle of elevation, and how important are figures, drawing figures in heights and distances problems. Now, this video is a continuation of the same. We are going to solve a couple of more problems. Trust me, after watching these two videos, you will be able to solve heights and distances problems at ease. Without any further delay, let's move on into the session. Okay, the first question for the session today is an aeroplane flying horizontally 2 kilometers above the ground and going away from the observer is observed at an angle of elevation of 60 degrees. Okay, after 10 seconds, the elevation is observed to be 30 degrees. Find the uniform speed of the aeroplane in kilometers per hour. Okay, so now first let's convert this question into a figure. Okay, let me quickly draw a rough figure here. There's an aeroplane flying horizontally 2 kilometers away above the ground level. Okay, let this be the ground and there is an aeroplane flying here. Okay, let's suppose this is the position of the plane. Okay, and it's going to be 2 kilometers vertically from the ground level. Okay, it's given above the ground and going away from the observer. Let's suppose the observer is here. Okay, let's call the observer C. Okay, from here the observer is here. So this plane is going away from the observer. Okay, horizontally it's going. So it chases a path that's parallel to the ground. Okay, so it goes like this. Okay, a position of it after 10 seconds, after 10 seconds. Okay, after 10 seconds, let's suppose now you are supposed to mark only the distant measures here. This time and speed, you're not supposed to mark it. So what you can do is you can mark it with a pencil and write time, okay, or a different, I'm using a different color pen here. So I'm going to write that time taken by it is 10 seconds. It's not the distance, but the time. Okay, the measures that are marked on the on the figure that you make should only be distant measures, okay, or the length measures. Okay, so now A to B, it travels in 10 seconds. Okay, and it is okay. Now we'll look into it. Now the observer, I've marked him here and not just right below the aeroplane. Why? Because it is given that the observer is, observing the plane at an angle of elevation of 60 degrees. So he's not directly looking up, but with an angular, okay, an angular sight. That is, he makes his angle of vision makes an angle of 60 degrees with the horizontal, that will be the ground level. Okay, the horizon. Okay, so with that, his angle, his side of vision is going to make an angle of 60 degrees. So he's going to look somewhere like this. Now, after 10 seconds, the angle of elevation reduces to 30 degrees, right? So it's always like that. When the object goes farther away from you, the angle of elevation will be less. You need not lift your head too much. But the one at right on top of you, you will raise it to the maximum. And slowly you will start reducing the raise of your head as it moves away from you, right? So after 10 seconds, since it's moving farther away from him, his angle of elevation goes on to be 30 degrees. Okay, so this is our figure. Okay, so A, B, C, D, E. Let's complete marking, labeling the figure. Okay, and then we are able to see that these two are both are perpendicular lines, so those are parallel to each other. Okay, and they will be equal. Right. So this forms a rectangle. Now, what are you supposed to find? You're supposed to find the uniform speed of the aeroplane. Okay. You're supposed to find the speed of the aeroplane when it travels from A to B. Okay. Now, how do you usually find the speed? The speed is given by the distance by time. So the time is already with you. If you find the distance of A, B, okay, you call it D. If you find the distance between A and B, your work is done. You just can divide the distance and the time and then get the speed. Okay, now what is given? It is given that the speed should be in kilometer per hour. So please do mark it with a pencil somewhere on the paper that the speed has to be found out in kilometer per hour so that you don't miss on anything. Okay, so if you express it in some other unit, it'll go wrong. Okay, you won't get the complete marks for it. Okay, so now I've made the figure again. So let's just see. So this is A, this is B, position of the aeroplane first and then later. It took 10 seconds for it to travel here. And then the angles of elevations are marked. And then now we have labeled the diagram. Now we'll see. What are we supposed to find? We're supposed to find this D. Okay. So now we have two right triangles. Okay. One is triangle ACD. And then the other one is triangle BCE. Okay, this big triangle, right triangle, and the small right triangle. Okay, so now observe there is a rectangle also. This, if this is D, this can also be called as D, right? Because these are opposite equal sides. So if we find the measure of this D, this will automatically follow, correct? So now let's see how to find that. Now, first I'm going to consider this triangle, smaller triangle ACD. Okay, I'm trying to find out the base because with that base it will be easy for me to find this D. Okay, so consider triangle ACD, and I know this angle measure that's 60 degrees, and the measure of the side that's opposite to 60 I know, and I need the adjacent. So opposite and adjacent relationship is given by tan. So tan theta is equal to the ratio between the opposite and the adjacent. So the opposite given to be 2 and the adjacent we are supposed to find out. And what is tan 60? Tan 60 is root 3. So from this it is very clear that CD is equal to 2 by root 3. This is a standard angle. You will get it in the table. Okay, so CD is equal to 2 by root 3. Now always remember that the denominator of any fraction should not be irrational at any point in time. We need to convert it into rational number for us to be able to operate with it. So how to rationalize root 3? If I multiply by another root 3, I get the I get a rational number 3. Okay, so the rationalizing factor of root 3 is root 3. Now I can't divide only the denominator by root 3. I need to multiply the numerator also by root 3. Okay, sorry, I cannot multiply the denominator only by root 3. I'll have to multiply even the numerator by root 3. This is how we rationalize the denominator. Okay, I hope you all remember. So this is nothing but 2 root 3 by 3. So because root 3 into root 3 is 3. So let's mark CD. We have found it as 2 root 3 by 3 kilometers, because the other measure is in kilometers. This will also come out to be in kilometers. Okay. So now I'm going to take the other triangle and find the complete base of that also, the base of the big triangle, the bigger triangle. Okay. So let's consider a triangle BCE. Okay, BCE. In that again, tan 30 will give me the opposite of it. Okay, the opposite is BE by CE. Look at this. This is the full triangle that we are dealing with. Okay, so this 30 degrees, tan 30 will be opposite by adjacent. Okay, so tan 30 is nothing but 1 by root 3, that is equal to BE by CE. So from this, BE we know is 2 kilometers. We have already marked it. Okay, so let's replace, substitute the value of BE to be 2. So from here we can find CE, that's equal to 2 root 3. So we can mark CE as 2 root 3 kilometers, right? Okay. So now what am I supposed to find? I'm supposed to find I'm supposed to find the speed of the aeroplane, speed with which it has traveled from A to B. So I'm going to find the speed by distance by time formula, because I already have the time. I'm going to find the distance. The distance I've named it as D. Now that D is equal to DE, right? So now how to find DE? DE is easy to find because I can, from CE, if I subtract CD, I get DE, right? From this complete part, I'm taking away this part to get this DE. That's why we found the bases out. So this is just like solving a puzzle, children. Just see how to find the unknown, mark the equal parts, and try to make it easy for you to find the unknown, okay? So the DE is found to be 2 root 3. Okay, the D, no, the DE is what we are supposed to find out. Sorry. So now DE is named as D. So and CE is 2 root 3 minus CD is 2 root 3 by 3. So now how are we going to solve it? We take LCM to subtract this because we have a fraction here. So 1 into 3 gives me 3. So the numerator is also going to be multiplied by 3. So 3 into 2 root 3 will be 6 root 3. You multiply the rational numbers and then put the irrational number like that only. So 3 into 1 gives me 3. So I just multiply the numerator by 1. So I get back the numerator. So 6 root 3 minus 2 root 3. These are like surds. This can be subtracted. Just treat it like your variables. Okay. So like variables, you just subtract the coefficients and place the variables, right? Same way, 6 root 3 minus 2 root 3 will be, you will subtract the rational number. 6 minus 2 is 4 and you get the root 3. Okay. So 4 root 3 by 3 kilometers will be the D value. So I have found out the D. Let me mark it on the figure. So I have found out AB to be 4 root 3 by 3 kilometers. Okay, now what am I supposed to find? I'm supposed to find the speed. Speed is distance by time. Not only that, I should not find speed in whatever units I want to. I need to find the speed in kilometer per hour. So the distance is already in kilometer, but the time is not in hours, it's in seconds. So let's first convert the time into hour. Okay, so to 10 seconds will be equal to 10 by 3600. Okay, so always when you have to convert the seconds into hours, you have to divide it by 3600 because 1 hour contains 3600 seconds in it, right? Okay, so now my speed is going to be distance by time. My distance has been found out to be 4 root 3 by 3. By time is 10 by 3600. So what do? I have a complex fraction. I'll multiply by the reciprocal of the denominator. So I have 3600 by 10. So this is 1200. 0 gets cancelled. So this is 480 root 3. Okay, so you can leave it as a surd like this. Okay, this is kilometer per hour. Or if you want to express it as decimals, you need to multiply it with 1.732. I always suggest that you remember root 2, root 3 and root 5 values for easy calculations and swift calculations so that you don't need to check the tables for such simple values. Okay, so it's 831.36 kilometer per hour. So this is our answer. So what are we left with? We need to write the final answer statement. Therefore, the distance traveled, the speed of the aeroplane. Okay, so that's what we are supposed to find and found out that. So therefore, speed of the aeroplane is 831.36 kilometer per hour. We have expressed it in kilometer per hour. The next question is, as observed from the top of a 80-meter tall lighthouse, the angles of depression of two chips on the same side of the lighthouse in horizontal line with its base are 30 degrees and 40 degrees respectively. Find the distance between the chips. Not only that, give your answer correct to nearest meter. Okay, let's quickly draw a rough figure now. Okay, so I have a lighthouse and the lighthouse height is 80 meter tall. Okay, it should be a straight line. Okay, straight vertical line. Now the angles of depression of two ships on the same side of the lighthouse. Okay, same side. Okay, there are two ships like this on the same side. It's not here and here, but on the same side. If it's opposite side, then you have to place the other one on the other side. Okay, on the same side of the lighthouse in horizontal line with its base. So it means that all three are on the same horizontal line. The base of the lighthouse and the two ships, okay, are 30 and 40 degrees respectively. The angles of depression, meaning from the top of the lighthouse, when you look down at the ships, okay, the angle, the eyesight, the line of sight makes an angle of depression of 40 and 30 respectively. Okay, 30 and 40 respectively. Now let's understand how to mark the angles of depression. Okay, now 30 will be for what and 40 will be for what? See, the same, now I tell you a logic. See, when you have a ship closer by to you, the angle of depression will be more because you have to bend down more than to see a ship that's little farther away from you, correct? So if you see, this ship is closer to the observer, so that will make the larger angle than the ship that's farther away from the observer, correct? So with the horizontal line, okay, with the horizon that is parallel to the base, I'll have to make the angles. I've always told you the angle of depression should be marked with the line of sight along with the horizontal line, okay, the line of horizon, okay. Now you draw a straight line from there, and then that's parallel to this. From there you mark the angles. Now always you will have to convert the angle of depression into angle of elevation, right? So this is the top of the lighthouse. Let's name the lighthouse CD. From C, whatever the angle of depression is towards B, the same degree will be, the same angle will be formed from B to C. Okay, so this one will be 40 and C to A is 30 degrees. So from A to C is going to be 30 degrees. Okay, so mark this. Now we have converted the angles of elevation, depression into angles of elevation. Okay, so now this is our new figure now. So we know the height of the tower. What are we supposed to find? We are supposed to find the distance between the two ships. Okay, let's name it D. We are supposed to find the distance between A and B. Not only that, we have to find it in the nearest meter. Okay, so this is our question. So we have made the figure here. Okay, the lighthouse is CD and then the ships are A and B. The angle of elevation has been marked now. The depression has got converted into angle of elevation. Now we are supposed to find this D in nearest meter. Okay, write it in pencil somewhere so that you don't forget to express the answer in the right unit. Okay, so all parts of the question has to be answered. Otherwise, you will not be getting the full marks for it. Okay. Okay. Now, how to find this? So, of course, we are dealing with the opposite to the angles and the adjacent we are supposed to find out. So, obviously, we'll be using tan, right? So, how many right triangles we have? We have triangle CAD and then triangle CBA. Okay, so we have CBD, sorry. Okay, the bigger triangle is CBD. Because CBA is not a right angle triangle. CBD and CAD. These are the two triangles we've spotted of the right angle triangle. Okay, so let's go about solving it. First, we'll take the bigger triangle. Okay, so consider triangle CBD. Okay, so as usual, we'll be using tan 30 because we are dealing with opposite and adjacent. So AD divided by the adjacent side is going to be BD because we are taking this big triangle. Tan 30 is the angle, 30 degrees is the angle, so tangent of 30 I'm finding it out. So that's the ratio between the opposite, that's CD by BD. That's AD by BD. So with that, tan 30 is nothing but 1 by root 3. 1 by root 3 is 80 by BD. So from this, it implies that BD is equal to 80 root 3. Just cross multiply, you'll get the value. So BD, the complete BD has been found to be the 80 root 3. Let's keep it like that as of now. Okay, so we found it as 80 root 3. Now we'll consider the next right triangle that we have. Okay, so what's the next right triangle? So now we'll consider the smaller triangle. Consider triangle CAD. So we have tan 40 equal to opposite by adjacent. That's 80. Now, from here you know that AD is equal to 80 by tan 40. Now 40 degrees is not a standard angle. You have the tan tables with you that will be provided in the examination for you. You can look into that and get the tan 40 value. So tan 40 value is 0.8391. Okay. So 80 by 0.8391. Okay, as I always tell you, be very, very careful when you deal with decimal numbers, addition, subtraction, multiplication, division, anything you do it properly. Okay, so now I have a decimal number in the denominator. Let me try to eliminate the decimal point. So what do? I multiply by 1 followed by 4 zeros. Why? Because I have 4 numbers after the decimal point. Both to the numerator and to the denominator I will do to eliminate the decimal point. So my AD gets converted as 8 followed by 50. Okay, that's 8 lakh divided by 8391. Okay, so now this one you'll have to use the long division method to divide. Please use the rough column. Okay, so the rough work has to be done on the relevant page wherein your solution is given. Okay, so when you divide it, you're getting 95.34. Okay, and that is in meters. Okay, so this is your solution as far as AD is concerned. So this is 95.34. Okay, so this is in decimal. So let's convert BD also into decimal. How do you convert it? It is 80 root 3. So you're going to multiply 80 by 1.732. Okay, so always remember so that you can save time. Okay, when you deal with root 2, root 3 and root 5, 1.732. Okay, so that gives you 138.56. So this measure is nothing but 138.56. When you multiply decimal numbers, please place the decimal point properly. Okay, so now we have found out the BD and AD. Now, what are we supposed to find out? We are supposed to find out AB. So with these measures, will we be able to find out AB? So let's just quickly look into it. So let's make some space for ourselves, okay, before we continue. So I'm supposed to find AB. My AB is nothing but from BD. If I remove AD, I get AB, right? So BD is 138.56. From that, I'm removing 95.34. So what do I get? I need to subtract it, okay? So 138.56 minus 95.34 gives me 43.22, okay, 22 meters. Now, what was the question? I'm supposed to express it in the nearest meter. So I need to round this off. Look at this. After the decimal point, the numbers are less than 5. Okay, so when I have to convert it into the whole number, I need to look into the digit that's next to it. If that particular number is less than 2, then you will approximate it to the same number, 43. If this number is greater than or equal to 5, you will approximate it to the next number, that's 44. Okay. So here it's less than 5, so this is nothing but approximately equal to 43 meters. So now we have to write the final answer statement. Therefore, the distance between the ships is 43 meters. So this is very important. The figure and the final answer statement is important. With this, we have come to the fag end of this video. We are done with trigonometry. Okay, so please visit all the videos that I've uploaded under this topic, trigonometry, for better understanding. Okay, so practice well. Do more of heights and distances problems after watching this video. If in case you have any challenges, please feel free to post it on the comment section. I will definitely address to it. And then I'll make a video addressing to all your doubts. Okay, so with that, we are completing the trigonometry. In the next session, we'll see a new topic. Okay, so if you have any suggestions, you can suggest that also. Put it in the comment box so that I will teach you that particular topic. I hope you enjoy my videos. If you enjoy it, if you like it, if you understand the concepts clearly, please do like the videos, comment, give your comments, share your comments with me in the comment section, and share my videos with others so that it reaches all the deserving students. Thank you all.